Hello guys, today we're gonna talk about Celestial Sphere by Zain al-Bughdadi. What is celestial sphere? The celestial sphere is an imaginary sphere of gigantic radius with the Earth located at its center. The poles of the celestial sphere are aligned with the poles of the Earth. The celestial equator lies along the celestial sphere in the same plane that includes the Earth's equator. What is the zenith? Zenith is the imaginary point that is directly above a particular location on the celestial sphere. It is vertically opposite to the apparent gravitational force, directly opposite to the gravitational pull. It is the highest point on the sphere and thus the farthest up from the gravitational force. What is the celestial sphere and why it is still useful today? The celestial sphere is a map of the sky that has latitude and longitude, as this allows astronomers to precisely locate any celestial object. It is still useful today. And now I will show you a video that explains the celestial sphere.
We know from Earth that we can take our own rotation axis and use that to divide the Earth along the equator into northern and southern hemispheres. But that also means that we can now draw parallel lines to the equator, giving us what we call parallels of latitude. So we start at 0 degrees at the equator, and we arrive at 90 degrees north at the North Pole and 90 degrees south at the South Pole. Now, in addition to parallels of latitude, measuring north and south, we also want to be able to measure from east to west. So by international agreement, the prime meridian is an imaginary line that goes through the North Pole, through Greenwich, England, at the Royal Observatory, all the way down to the South Pole. And then we can simply measure east or west in terms of meridians of longitude. So, for example, here in Baltimore, we are at 39 degrees north latitude, 76 degrees west latitude. A southern example would be Cerro Paranal in Chile, that's 24 degrees south latitude or 70 degrees west. And Rome, Italy is 42 degrees north and 12 degrees east. So that places Rome at about the same latitude as Boston, Massachusetts. Now, that is how we define every location on Earth. And we're going to use an analogous system to define every location in the heavens. So let's bring our Earth inside of the celestial sphere, and we'll once again extend our north and south poles to form the north and south celestial poles. We'll extend the equator to form the celestial equator. And just as we did before with parallels of latitude, we can now draw parallel lines to the celestial equator, only we refer to these as parallels of declination. So we measure declination as 0 degrees from the equator all the way up to positive 90 at the north celestial pole, and then all the way down to negative 90 at the south celestial pole. Now, we cannot simply take our meridians and apply those to the sky as well. The reason for that is because the Earth is rotating, and therefore the meridians would need to rotate as well, and that would make such a system fairly useless to us. Instead, what we'll do is we'll take the annual path of the sun, the ecliptic, and we'll note the location that the sun is on in March when it arrives at the vernal equinox. Since the Earth rotates on its axis once every 24 hours, this gives us a 24-hour clock face that we can write onto the celestial equator. So when we draw parallel lines to this clock face, we then get hours of right ascension. So again, think of not so much as hours of time, but think of it instead as hours on a clock face. For example, Rigel in the constellation of Orion has a right ascension of a little more than 5 hours, about a quarter of the way onto the 6th hour circle. So that gives Rigel a right ascension of 5 hours and 15 minutes. And since it's south of the celestial equator, that gives us a declination of minus 8 degrees and 12 minutes of arc. Remember, we can take a single degree and we can split that up into 60 minutes of arc. So this coordinate system, since it's based on the celestial equator, we call this the equatorial coordinate system. And it's a really convenient way for us to define every single point.
Why do scientists use the celestial sphere if they know it is inaccurate? The advantage is that astronomers can state the location of an object so that any astronomer at any location on the Earth can find that object in the sky. Does the celestial sphere rotate? Due to the rotation of the Earth on its axis, the celestine sphere appears to rotate daily from east to west, and the stars seem to follow circular trails around 2 points in the sky. How many celestial spheres are there? Each sphere contains a specific substance or body and communicates motion to its neighbors. The Earth is surrounded by spheres of water, air, and fire. 7 spheres for the Sun, the Moon, and 5 known planets: Mercury, Venus, Mars, Jupiter, and Saturn, and 1 sphere for the fixed stars.